Okay, this video has to do with proportions. It's a recall from Algebra 1. You want to remember that proportions represent an equation that states that two ratios are equal. And when we solve proportions, we go through a process called cross-multiplying. Okay, so here we have 24 times 20 being equal to 16 times x. That would be 480 is equal to 16x. And when we divide by 16, we get x is 30. Please make sure you pause this video as you go through in order to write down all the notes. All right, again, we need to cross multiply. But what we need to remember is that we have a binomial here, and that should stay in parentheses so that we can distribute that 3. So 3 times the quantity x minus 9 is equal to 4x. Distributing the 3 gives us 3x minus 27. So x must equal negative 27. All right, so we have some properties of proportions. So we can write equivalent proportions by flipping both of our fractions, right, which are ratios. We can flip both of our ratios upside down and get the same. We can interchange, so we can take both numerators and interchange them with one another, thereby both denominators and interchange them. And we can also add the value of the denominator, so this b would get added and this d is going to get added. So there are just a few of the properties from Algebra 1 that you need to recall about proportions. This is so when you're working with a partner, you may have the problem set up differently, but in the end, you're going to get the same answer, because when you cross multiply, no matter where the answers are, no matter where the operations are, you're always going to be multiplying the same two things. So for example, in number 1, AD is equal to BC, and it's still AD is equal to BC. Okay, so we're not changing the fact that A is being multiplied by D and B is being multiplied by C using the extremes means property. All right, so how does this work with geometry? Well, we're going to be working with similar figures, and when we discuss congruence, we did discuss a little bit of similarity. So we're going to be discussing how side lengths are proportional, thereby using proportions to solve. So if we're given this proportion, I'm going to write 4 true proportions. So I'm starting with what I was given. I'm going to rewrite it 3 different times using the properties from the previous slide. So I'm going to flip my numerator and denominator. I am going to take both numerators together and set them equal to both denominators. And I'm going to add the value of the denominator from the original to each numerator. Okay, in example 2, we're given this proportion. So we have BD over DA is directly proportional to BE over EC. So all we need to do is perform a little bit of substitution. So BD would be equal to x minus 3. So let's look at that for a second. If the large blue segment is x and the yellow segment is 3, then the purple part must be the big segment minus the small segment. Okay, so for example, if x was 10, then we know the purple segment must have been 7. All right, so we perform some substitution and set up. Now we need to cross multiply. Again, don't forget your binomial needs to be in parentheses as shown. We distribute. On the left, we multiply on the right. Add 18 to both sides and divide. So now that we know x is 12, we need to go back and answer the question, and that says to find BA and BD. So since BA was x, we know the answer is 12. But BD was the difference between BA and DA. So 12 minus 3 is 9. Okay, example 3. We have a blueprint that shows a scale drawing of a cell phone. Quite an old cell phone. So we have the length of the antenna on the blueprint is 5 centimeters, however the actual length is 2. So we need to find the scale of the blueprint. So when we do that, we need to take the ratio of the length of the drawing over the actual length and then reduce it till we get the denominator as 1. So we have 5 over 2. Divide 5 by 2 to get 2.5. So that the scale of the blueprint is actually 2.5 centimeters to 1 centimeter. Okay. Our next example, which actually should say example 4, not example 5, but it's coming out of the textbook. So if you follow the textbook, this is example 5. We buy a 3D scale model of the Reunion Tower in Dallas, Texas, and the actual building is 560 feet tall. Our model, however, is 10 inches tall. The diameter of the dome in our scale is 2.1 inches. We need to find the actual diameter of the dome. Okay, so we need to work with our proportions. So in this case, we put the model over the actual, and our first fraction represented how tall, and the second ratio represents the diameter. And notice we cannot interchange where the model and the actual are. If we are putting the model in the numerator, it always has to stay in the numerator. Okay, so the model and the actual building. And in order to solve, we cross multiply. Okay, so we get 117.6 is the actual diameter. So if we want to know how many times as tall the model is as the actual building, okay, there's our diameter answer. We have to simplify the ratio and multiply it using a conversion factor. So that means we need to take our 560 feet over inches. We want to get rid of our inches. Okay, so we have to put inches on top, feet on bottom. 1 foot is equivalent to 12 inches. Now our inches will cancel out with inches, our feet will cancel out with feet, so we have no units left, and then we just multiply the numerators and divide by the denominator. So that means the actual building is 672 times as tall as the model. Okay, you're responsible for doing some textbook problems at this point.